much stuff on there. Like it's going to take up too much space, in my opinion, but I need you to be able to read it. So what I would do after is I would compress it once I'm done. Okay, so for probability, I would call this probability and odds. We just, like it has both components to it. So from probability to odds, you're supposed to be able to convert. Okay, you're supposed to be able to go from probability to odds. So if your probability is 7 out of 10, then the odds would be 7 to 3. These two add up to 10, right? That's something that I would make a note of. So that's something you should observe. Another thing, I'm going to give you another example. If you have 0.35, that's a probability. What is 0.35 as a percentage? You multiply that by 100, right? If you have a decimal, just multiply that by 100, you get 35%. And that is what? 35 out of 100, correct? 35 out of 100. And now you can turn this to odds. This would be 35 to 65. And remember, both of these add up to 100. That's something you should observe. So you're going from decimal to percent to fraction. I would always want you to ultimately first go to a fraction and then go into odds. Okay? So this would be like my first little box here. And then maybe next to it I would have going from odds to probability. And I would have an example here. Odds of rain means, what that means is rain compared to not rain. So if the odds of rain would be 3 to 9, if it's 3 to 9 like that, how would you turn that into a probability? We would go, probability would be, the first thing I want you to do is 9 plus 3. And then you would put the 3 on top. So it's 3 over 12. If you want probability of not rain, how would you go if it says probability against rain or not rain? You would still be out of 12, but instead of the 3, what would you grab? You would grab the 9, okay? And so if you look at these, they add up to 3 and 9 is 12, so it's 12 out of 12, which is 1. And what I'm going to do here is odds to odds. I'm going to fit that in here. Just flip. Okay? Odds 4. Let's say it's 3 to 1. Odds against. 1 to 3. Sorry, that's a little crowded there, but again, you can rewrite it. You can make this work. So this is like a basic. This is very, very basic. This is something I would expect you to know how to do. And what's the maximum you can ever have in terms of probability? It can never be more than 100%. It can never be more than 1. So if they ever ask you what's wrong with this, like if it's let's say it's 5 over 4. You're like, wait a minute, 5 over 4 is 1.2. 1.2, that can't be. That's bigger than 1, right? Can't have that. So I'll put that max is 100% or 1. Okay, that's something, a very important concept that I need you to understand. And you know what? I'm going to also say that probability, and again, I'm just brainstorming here. Probability is favorable outcomes over, what is it? What's at the bottom? Total, yes. Total possible. That is also, I would have that, it's kind of like a formula. And odds, it compares favorable to non-favorable. And you know what? It doesn't hurt to say that both of them would add up to the total. Like if you combine both sides of your odds, that amounts to the total. It's always a good check. Next, I want to talk about, let me see here, theoretical probability. I would want you to know that this is what we expect in the long run. What's the other one? Experimental probability. This is based on actual events or trials. So I'm going to give you an example real quick here. If this is 1, 2, 3, 4, and that's a spinner, if you were to have, right, 1, 2, 3, 4, and this would be outcomes, number of, let's say this happened 10 times, this happened 20 times, 25, and this happened 5 times. Okay? Theoretical probability of rolling a 3 would be 1 out of 4, because you go back to this one. Experimental probability of rolling a 3 would be 25. I'm going to use highlighters after. 25 over, this is 30, and another 30 is 60 in total. So that 60 is what would come down here. So let me use a highlighter, right? This 60 came over here. So you understand that the experimental is based on, I'll write down results here. So use your spinner to come up with these results. Which one is more accurate to make a prediction in the long run? Like if we're spinning it 2,000 times, which of these probabilities should you be using? Theoretical probability. We expect it to be 1 out of 4 times that it will land on 3. Okay, so that's that. Another one, another concept that is important. So this is my theoretical probability concept block. Then there is dependent events. First event affects second. Keyword is no replacement. So how many do we, 3, 6, 9, 12, 4. So we've got 23 students, more or less, I think so. Let's say I'm making groups up here. So what's the probability of me picking Adam at the very first time? It would be 1 out of 23. Let's say I remove a student. It wasn't Adam, right? What's the probability now of me selecting Adam? 1 out of 22, right? That's as simple as that. You just notice that something happened for that second event. The first one affected it because I haven't replaced Robbie, right? When I picked Robbie, I didn't replace it. It's already part of this group. So now I'm picking another student for the second group. So I'm removing outcomes. I'm removing the total at first. Okay, so independent. First event doesn't affect second. Sorry about the scribble. Replacing items. Like, so if you replace it, or another one would be dice. If you roll a die or a pair of dice, you're not removing anything. Even if you roll and you get a 1, you're not removing the 1. You're just recording it, so it doesn't affect it. Okay. Should I have an example? I think I'm going to leave it for now. And the next one is expected value. This one, you need to have the formula. So this is probability of prize 1 times the first prize. Usually a dollar amount, plus probability of winning a second prize times that prize. I should go 1 here. I should go 2 there. And how do you know that you can win a prize? They will tell you. You win $3, $10, $1 million. It doesn't matter. If there's a way to win, there should be a probability attached to that winning. Okay. And so this would keep going. I will go dot, dot, dot. But at the end of the day, you will subtract the cost. This is always there. Dot, dot, dot just means you would keep adding for as many prizes as there are to be won. Okay? I will give you an example here. 500 tickets sold, and I'll say that there's 1 ticket wins $50, 10 tickets win $5, 50 tickets win $2, let's say. This is a bit of a table. Let's say costs $10 to play. So there's a raffle, and 500 tickets are all sold, and every single ticket costs you $10. How would you calculate the expected value? It'd be 1 in 500 chance of winning the $50. Then there would be 10 in 500 chance of winning the $5. There would be 50 out of 500 chances of winning $2. And then, last but not least, minus the $10 that it costs to play. This always goes at the end there. Should I calculate this? I can, why not? 1 divided by 500 times 50. So this would be 0.1. Yeah, okay, that was, something went wrong here. 1 divided by 500 times 50. Oh yeah, this is also 0.1. And then it's, this is 0.2 minus 10. So 0.4 minus 10, that would be negative 9.60 would be the answer. And so bad for player because of negative, good for host. Okay, and that gets me to the last part here for expected value. Somewhere on here, you should say to yourself that expected value, if it's positive, good for player, bad for host. If it is negative, can you see that? This is bad for player, good for host. That is definitely. So mention sign of answer. I'm gonna make sure you highlight that. Well, you do whatever works for you, but if you don't mention the sign of your answer, if you're trying to justify whether or not you should be playing, it's not gonna count, and it's a freebie. It's a freebie. Let's say you get your expected value wrong, completely wrong, but if you answer B based on the sign of A, you still get this mark. Easy mark. Okay? I used up a whole sheet. Not cool, right? But that's me. I wasn't thinking, I wasn't planning this, I was just writing down what came to mind. Are there more things? Yes. I think there are more. For example, an outcome table. So I'm going to continue on the back side. These are extras, right? Outcome tables, example, 2 3-sided die, or dice, I guess I should say. So if you have that, you go 1, 2, 3, 1, 2, 3, because it says they're both 3-sided. So this would be the sums, right? 2 and 1 is 3, 4, 5, 4, 5, 6. Okay? There are 6 outcomes. Probability of rolling a sum of 3, let's say. Guess what? Every single question is going to be out of 6. And there's only 2 outcomes that meet that criteria. I would just have this on my study sheet. I would just say this is right here. This is what I used to come up with the 2. Probability of rolling even. How many even sums can you have? Let's see here. There's this one, 2. Right, 1, 2, 3, 4, 5. There are 5 even sums there. And I will make a note that, right, the circled ones are my even sums, okay? Did I make a mistake? There's 9, right? 1, 2. Let's do Spanish. 1, 2, 3, 4, 5, 6, 7, 8, 9. Is that cool? I speak Spanish. Yeah. It still doesn't make it right. It's still 9 and you put down 6. How does that have anything to do with? Sorry about that, guys. Thank you. Is this still right? The top numbers are still right, correct? On an exam, how would this be marked if you put 6 here? You would lose here, but you would not lose in part B because we understand that you just got it wrong at first, but you know what? I think you would only lose half a mark because if you had the outcome table, you tell us you know what you're doing. Okay, it's just a glitch. Okay, it's like a Mr. Dirksen moment, right? How many of those have I had this semester? Once or twice? No, that's generous. So outcome tables. Is there anything else right now that I could be adding? Perhaps. It's up to you right now. It's in your court. Okay. If you want review, here I'll give you some pages to try. In your booklets, 54 to 68. That's a bunch of pages there. And I will post the key in chunks like this. 90 to 92 has a chapter test if you want to give that a try. So yeah, it's a lot, but some of you will actually do it, so why not?